All right, good morning. What we are going to do now is jump into probability. That is what Unit 8 is going to be on probability and some data. And just kind of taking a general overview look at it. There are specific applications of probability in the Algebra 2 curriculum that we use that we may not necessarily get to, but we are just kind of using this so we've got kind of a general working idea of how this is, and so that those of you who continue to go on and do more math kind of remember how this works and all that. So we're going to talk about theoretical probability, independent and dependent events, and complements, right? Not the kind of compliments where, boy, your hair looks nice today. Different kind of compliment. So let's get started. So we've got and our first thing we're going to talk about is probability and theoretical probability. Now, probability is basically the likeliness that something's going to happen, and we come up with a way to numerically quantify it. And theoretical probability means that in theory, so not necessarily in practice, but in theory, like how, and a really good example of that is if you flip a coin, right? And you flip a coin 50 times, right? The theoretical probability is that if you flip it 50 times, 25 of those times it's going to be heads, right? And then, if you have a coin, so you do flip 50 times, right? You should have, theoretically, you should have 25 of each, right? That's theoretical, right? But in practical, right, or experimental probability, right, experimental probability, you might get 30 heads and 20 tails, or you might even get like 5 heads and 45 tails. Now, it's not likely that you're going to get that, but it is a possibility. And so that's what separates like theoretical from experimental probability. Theoretical probability is that on paper, that's what this kind of looks like it's going to happen. Now, what actually happens is another story. So that's kind of a good way to think about it. And the more you do an experiment, the closer and closer it is to get near that theoretical line. All right. So when we talk about percents and what we get, right? And obviously, if something's 0%, that means it ain't happening. If something's 100%, that means it is always happening no matter what. Most things kind of lie in between. Um, and we do talk about probability as percents or as decimals. A lot of times it's decimals, right? So we'll have to be comfortable writing the decimals and then converting that back to percent. So let's try this. So it says you roll a standard six-sided die. Find the probability of rolling a five. All right. So think about a standard six-sided die. Now I'm not always going to do this, but you've got one, you've got two. It's your typical die, right? Die is singular for dice. In case you're wondering why I'm telling everybody to go die. That's not what I'm doing. All right, and this is kind of what they look like, right? So this is, 1, 2, 3, 4, 5, 6, right? And rolling a 5, all right, well, there's 6 possibilities, so that would be your number of possible outcomes. And then the number of favorable outcome, the favorable outcome is the one you want. So you want to roll 5, so there's only one possibility of that. So you have a 1 in 6 chance, or if you put that in the calculator, my brain's not quite up to speed yet, but thinking that's 0.167. 1 divided by 6 is 0.167, right? 0.1 or 0.16 repeating. We just say 0.17. All right, is going to be a probability. So that means about 17% chance that you will roll a 5. Now, for rolling an even number, right, you would look at how many possibilities you have that are even numbers, right? So you've got this one, you've got this one, and you've got this one. So you've got 3 different possibilities out of 6. So 3 favorable outcomes out of 6 possible outcomes. Simplify that, you get 1/2, and if you put that into a decimal, it works out neatly, and you get exactly 0.5. All right, so that is, generally speaking, a very simplistic view on probability, all right, and just how to do this and what theoretical probability is. So in a perfect environment, that's how it would work, all right. So I'll stop the video here and we'll pick you up at the next one.